Good afternoon and welcome to our last session of the 2021 Midwest Manure Summit, a discussion of biogas upgrading. My name is Heather Slusser and I will be your moderator today. I would like to introduce our panelists for this afternoon, Kevin Dobson and Nick Elger. Kevin Dobson is Vice President of Business Development with DTE Biomass Energy and has been with the company since 2007. In this role, he leads all the acquisitions and greenfield development activities for both landfill and dairy farm-based renewable energy products. The company develops and operates both renewable natural gas and electric-generated projects across the country. DTE's current portfolio includes 7 dairy-based renewable natural gas facilities, 4 landfill-based renewable natural gas projects, and 12 landfill-based electric generation projects. Kevin's responsibilities include identifying prospects, evaluating economic and technical feasibility, proposal development, contract negotiations, and scheduling and implementation activities. Prior to DTE, Kevin worked in Ford Motor Company's corporate business development group, focused on mergers and acquisitions within the auto industry. He received his MBA from the Ross School of Business at the University of Michigan in 2003. Nick is the program manager for the EPA AgStar program and serves as the agricultural lead with the Global Methane Initiative. In his role as program manager for AgStar, Nick works with the U.S. livestock industry, state and federal agencies, and biogas industry stakeholders to advance the development of biogas systems. While supporting the Global Methane Initiative, Nick helps advance anaerobic digestion of organic feedstocks globally for methane mitigation in energy production. Nick has over 6 years environmental management experience in government, private consulting, and nonprofits. He graduated from the University of Minnesota, where he received his Bachelor's of Science degree in Environmental Sciences, Policy and Management, and is currently a Master of Business candidate at the George Washington University. At this time, I would like to turn things over to Dr. Becky Larson.
For our last session today, we are lucky enough to have 2 really well-informed people to talk about biogas upgrading. I know this has been a pretty popular topic lately. There's been a lot of movement in this area. And so first, we're going to let Nick Elger start and give us some background information. Then as we transition to hear Kevin, we'll start with some questions. And then after Kevin gives his a few slides of background, then we'll open it up to a lot of questions. So please feel free to enter any thoughts you have into the chat box as we move forward. All right, it looks like Nick, you have your slides up there, so feel free to take it away.
Okay, great. Thanks, Becky and Heather, for the introduction. Thanks for having me join this session here. I always enjoy coming to the Midwest Manure Summit. I'm really bummed that it wasn't in person because I heard that it may have been hosted at the hallowed grounds of Lambeau Field, which would have been a really special venue. But here I am in Washington, D.C. In my house, but happy to be here with you all. I help manage the EPA AgStar program, and we are a voluntary partnership program at EPA that helps advance the anaerobic digester industry. And today I want to provide an overview of the anaerobic digester industry and provide some updates on some of our resources and some of the latest trends in the sector. A little bit of background on the AgStar program. Our bread and butter is helping to support agriculture producers, specifically livestock producers, advanced sustainable manure management. And primarily that means through anaerobic digestion and providing best practices and resources and guidance and tracking the industry and helping move the industry forward in any way we can with the aim of helping to reduce greenhouse gas emissions. We work really closely with federal government agencies. We're a partnership sponsored in part by United States Department of Agriculture, as well as hosted in EPA. And we work really closely with state agencies, nonprofits, universities of which the University of Wisconsin and maybe several other universities that are attending this meeting are a part of, and state agencies. And really, again, just help those advance the industry in any way we can. There are a number of voluntary methane partnership programs at EPA, which can be of assistance to you all in the market, helping understand renewable natural gas. AgStar, our focus is the agriculture sector, manure management. The Landfill Methane Outreach Program has a number of tools and resources and partners for the landfill sector and organic waste management. And our Methane Challenge and Natural Gas Star program at EPA work really closely with oil and gas companies, primarily focused on helping oil and gas companies reduce their emissions from their oil and gas operations, but more so their members are really interested in greening their pipelines and procuring renewable natural gas as a option and a supply to their customer base, which is really looking for that product. So these three programs really work closely together to help advance the knowledge and track the industry and help reduce emissions and understand the renewable natural gas sector. Want to provide a little bit of update from the federal government, particularly the EPA and USDA on the new administration that has recently come in, and some exciting takes on what's happened so far. So there's been a flurry of executive orders, some of which have had touched on methane emission reductions and agriculture emission reductions as well too. The first bullet there, the protecting public health and environment and restoring science to tackle the climate crisis, is focused on helping to reduce methane emissions from the natural gas sector. But it's great that methane is a priority gas to help manage for this administration. And a couple of nominees for USDA, or the nominee for the USDA secretary, Secretary Vilsack, was previously with USDA as a secretary and was highly involved with the biogas sector and really a great proponent of advancing anaerobic digestion, renewable natural gas. He helped really lead the development of the biogas opportunities roadmap, and I'm really excited to have him on board to continue to be a champion for biogas and renewable natural gas. Over at EPA, our nominee for our administrator, Michael Regan, previously worked in my same office at the EPA in the Office of Air and Radiation, prior to leading the North Carolina Department of Environmental Quality, where he was involved with a number of hog biogas projects and has a great understanding of the environmental impacts of those systems, how to integrate those systems and the energy into pipelines, and what some of the challenges the producers, the utilities, and environmental advocates have with those projects. So we're excited to have hopefully both of those nominees confirmed here soon and support the anaerobic digester industry. And the last point there was another executive order on tackling the climate crisis at home and abroad. And that directed the Secretary of Agriculture within the first 60 days to collect stakeholder input on how the USDA can help encourage voluntary adoption of climate smart agriculture practices that can result in measurable, verifiable carbon reductions. And I think biogas, renewable natural gas, fits squarely under opportunities for that, for climate smart agriculture. And that solicitation project is yet to be undertaken, but when it does, hopefully folks on the line and those interested in supporting renewable natural gas can provide their input to that effort and can help steer the direction of the federal government's support for this work. These next couple of slides are going to talk a little bit about the U.S. biogas market, particularly for the agriculture community. AgStar and EPA help or have a tracking of projects across the US and try to keep a pulse on what's going on in the industry. So I'll provide a couple slides on the latest and greatest. So EPA's greenhouse gas inventory tracks the US's emissions from all sectors across the economy. Particularly, this graphic shows the US's methane emissions by source. Methane gas is 28 to 36 times greater global warming potential than CO2, so it's a really powerful greenhouse gas. And you can see on the pie chart there that biogas makes up a big portion of the US's methane emissions. Agriculture specifically, from enteric fermentation, manure management, make up almost 40% of the US's methane emissions. So there's an enormous opportunity to reduce emissions from those sectors, and the waste sector as well too, with landfills and wastewater treatment facilities make up a big opportunity to capture that gas and utilize it for clean energy. This graphic here is data that's pulled from AgStar's livestock digester database. We have been tracking since our program began in 1994 digester projects that have been built, shut down, and under construction. And you're more than welcome to visit the EPA AgStar's website for all of this data. But you can see the trend in project development that's occurred for livestock digester systems grew pretty rapidly in the early 2000s, mid 2010s, slowed down for a few years, largely due to tax incentives and going away and renewable portfolio standards from states filling up, but recently has begun to tick back up as additional incentives through the National Renewable Fuel Standard and California's Low Carbon Fuel Standard credits, which are credits that provide an additional price on the gas that's produced above the price of the methane itself, which is really helping to drive project growth. This graphic tracks neatly along with those projects to show the emission reductions from projects in the livestock sector. So in 2019 alone, US livestock digesters reduced about 4.65 million metric tons of CO2. What does that mean? Well, the EPA has a really great greenhouse gas equivalency calculator. Just Google that. You can find it and learn about how to equate different gases to what that means in relative terms. So essentially what 4.86 million metric tons of CO2 is equivalent to is over 1 million passenger cars taken off the road per year, as well as over 530,000 homes energy use for 1 year. So biogas projects are having a big impact and helping to provide clean energy across the economy. Continuing with the trends in the sector specific to renewable natural gas, there are a number of projects. I would say well over 90% of new biogas projects coming online in the US are renewable natural gas projects. And that's driven largely by the incentives from California and the Renewable Fuel Standard. And this graphic here shows an example of a renewable natural gas project that's in a business model that is called a cluster project. Essentially, this is an example of California Bioenergy's Kern cluster in Kern County, California. Essentially, cluster projects take advantage of several farms in an area that each will build a digester, or there's a number of ways in which it can work, but this example, each farm had a digester on their farm through local distribution pipelines connected to a singular pipeline where the gas was cleaned and upgraded to pipeline quality gas, where it is injected into the natural gas pipeline and is then purchased downstream for use as vehicle fuel. And this project in particular has 15, I think, to maybe even up to 17 or 18 projects, or excuse me, dairies that are participating in this one cluster, taking advantage of economies of scale to reduce the cost per farm of the biogas upgrading and make it more economically viable. But this cluster uses, mainly is injecting gas into the pipeline, but also has electricity production at some of the facilities, and is a really great example of what's happening not only in California, but across the country with livestock facilities, multiple coming together to form a cluster to reduce the cost and to increase the number of animals and manure, essentially, that can be used to produce large volumes of renewable natural gas. And Kevin will get into a lot more detail about some of the business models and the nitty-gritty of how those systems work. These next couple of slides, I want to take a minute to highlight some interesting things that are happening in New York State as it comes to biogas and renewable natural gas. So in New York, they have their, I want to say, second in the country in number. California may have, California and Wisconsin may be third now in the country in number of biogas projects, but they have 35 projects at dairy farms, wastewater recovery facilities, and standalone food waste digesters. A number of big companies have them as well too, Kraft, Hood, and wastewater treatment facilities. That's kind of the state of the digesters in New York City. But a number of the projects are, especially the agriculture projects, are converting from electricity to renewable natural gas, largely because the incentives for renewable natural gas are so enticing and can provide much more revenue for the farms. So this is a graphic here. If you squint really closely, you can see the dots on the map are digesters. The ones with R's in the little green circle are digesters that are converting to renewable natural gas. So in this example, there's 7 projects in New York State right now that are converting from electricity to renewable natural gas. And we're starting to see that elsewhere across the country as existing digester infrastructure begins to age and their power purchase agreements with their electricity utilities come to expire, and the rates for electricity may not be as lucrative or enticing. They're switching to renewable natural gas because that energy value is so much greater. New York State also has a number of laws that are helping to support biogas. 2 of which I wanted to point out here today are the Climate Leadership and Community Protection Act, which calls across the state and across the economy to decrease greenhouse gas emissions and to consider methane gas as being 86 times the global warming potential of CO2. Anaerobic digestion and renewable natural gas are being viewed as a way to help decarbonize difficult to electrify end uses such as industry and to reduce greenhouse gas emissions from the waste sectors. So AD is playing a part in that law. And another law, the food donation and food scraps recycling law, which is going to be taking effect next year, is a law that requires large generators of food waste that produce more than 2 tons per week to divert those food waste away from landfills. After that food is donated, any remaining food scraps must be directed to food recycler within 25 miles, which could include an anaerobic digester or a composting facility. So that's a trend that's happening not just in New York, but other states across the country that are developing food waste diversion strategies to help move food waste out of landfills. And a great repository for that food waste is anaerobic digesters. And we're seeing a number of new projects being built because of those laws, as well as helping to boost biogas production at livestock producers' facilities or other existing biogas facilities. And a really interesting study that's happening in New York, a collaboration between NYSERDA, the New York State Energy Research and Development Authority, Cornell University, and Stony Brook University are coming together to put together two studies to look at how to optimize biogas systems on farms in New York State. Essentially, they're evaluating the business models, the environmental benefits of these different models, the economics of these different business models, and trying to create a template for if a new system is going to be built in New York State, what is the best model to hit all of those points, economic, environmental, and social. And so they're just beginning that study right now. EPA AgStar has been invited to be on the project steering group as an advisor, and Stony Brook's leading a lot of the research into the optimization, and Cornell is going to be taking on the part of advocating for that work and helping to get that information out to dairy producers and to others across the state. I'm really excited to see what the study finds, because I think the results could be useful and beneficial for other states to glean that information from and potentially do those evaluations in their own state to see what is the best model for biogas systems in their state. And then just to take things home, I want to go over some AgStar resources that I think you all will be really useful for you all in learning more about systems and some of the challenges that you all face in the work that you do. These 4 resources we just recently developed in this past year. One, the Biogas Toolkit. It's a web-based toolkit, which compiles a lot of the resources that EPA AgStar and other EPA programs, other focused on biogas systems, and pull them all together in one toolkit. And it's really a great resource to find, whether you're in agriculture, you're looking at municipal solid waste or wastewater, what are some of the resources that can help you understand how to develop these projects, understand the economics, the business relationships, all of the steps that are involved with developing these systems. So that toolkit is a really great resource. On the next, and these are all available on AgStar's website. We recently updated our project development handbook, which pulls together the latest information and knowledge and best practices for anaerobic digester systems. And that again goes through a lot of those best practices for developing, operating these systems. We just recently released our first edition of our operator guidebook. We worked really closely with a number of partners and are partnering now with the American Biogas Council to offer this resource. It's available on our website, but essentially it walks through the best practices for operators to ensure safe and efficient operations on their digester system. ABC, Michigan State University, and some other folks that are offering in-person training on AD operations are utilizing this guidebook as a supplemental resource for that as well too. And really interested to partner with anybody to help train on not only the operator guidebook, but any of our resources. That's what AgStar is here to do, is to help get this information out and to provide training and capacity building for folks in the industry on these resources. And the last resource that we developed is a really great checklist and guidance for what are the best practices that if you're going to build a digester system, you need to check the box on to make sure it is technically and economically feasible and meets the best practices for operations. This risk analysis checklist can be really useful for helping to reduce the risk of developing these projects. And the best practices that are in that checklist actually relate almost identically to what the Department of Agriculture is looking for when they evaluate grants and loans. USDA has a number of grants and loans up to $500,000 for a biogas system, and I think up to maybe even up to $2 million for their loans for digester systems. Don't quote me on those numbers, but they offer a number of funding resources for systems. And this checklist helps you make sure that when you're submitting that application, you're meeting all the criteria they're looking for. And it also helps make sure the system operates, of course, efficiently. Number of other resources listed here on our website. We have a number of success stories that dive into projects across the country, interviews with operators where you can get firsthand take from operators of these systems to understand some of the challenges and what they've learned as they've developed these systems. We have a number of market trends on our website that show the different technologies that are used, the end uses, emission reductions. And we have a website dedicated exclusively to renewable natural gas in the agriculture sector, and some information and resources there. And of course, all the other resources that I mentioned. And we offer webinars and trainings on a lot of our resources, and many of which are available recorded on our website. And that wraps things up. And there's a link to EPA AgStar's website. You can subscribe to our newsletter, which has information and resources about what we are coming out with. And we also have a hotline where if you have any questions about anything related to anaerobic digestion, EPA AgStar is happy to help answer those questions. And you can access that through our webpage, or you can contact me as well too. So thank you.
So I'll ask you a question as you stop sharing, and we can hand it over to Kevin. When you're seeing some of the new RNG projects, or even any of the digester projects, do they seem to be all developing in like specific states? Are we just seeing growth in one area? And do those states have incentives, or is it kind of just scattered all over?
Yeah, the growth is happening in a number of areas where there's high animal density areas. Really, the growth recently has been driven by the incentives from California. You don't have to be in California to take advantage of those credits, the low carbon fuel standard credits. As long as you can connect to an interstate pipeline and you can show that the gas can virtually connect to California, you can take advantage of those credits. So there's a lot of hog systems that are going in North Carolina, Missouri, Utah. You saw those systems in New York State are connecting to the pipeline and sending the gas to California. And so really anywhere. A lot of California itself has a number of large projects that are going in. That's probably where the most new projects are planned and under construction right now. But all across the country, there's growth picking up.
I will have Kevin introduce some things, and then we'll get into some more questions. So thanks for getting us started, Nick. And Kevin, feel free to take it away with the next part.
Okay, well, hello everyone, and thanks Becky for inviting me to this summit. And I guess I'll start just by echoing Nick's disappointment that we're doing this via Zoom as opposed to in person there in Wisconsin. That would have been preferable. So but maybe next year we can kind of do all this in person. So as Becky mentioned, I am here today to talk to you guys about the creation of renewable natural gas at dairy farms throughout the United States. I think a lot of what Nick touched on, I certainly will provide maybe a little bit more details and maybe something from the perspective of a developer and operator of these RNG projects. So let me go through what I want to do today. I thought I'd first just provide a quick overview on who we are at DTE, but definitely want to spend most of my time talking about what's happening in this renewable natural gas space. I'm not sure everybody listening in maybe is on the same knowledge level as it pertains to renewable natural gas, or I refer to it as RNG. So we'll start with just a high level overview of both how and why renewable natural gas is created at dairy farms. I'll focus on the benefits of these projects to the host dairy farm as well. And then we'll finish up my presentation by discussing the demand side of renewable natural gas and what makes a good host dairy farm for a project. So just a quick introduction here for DTE, if you're not familiar with who we are. Our parent company, DTE Energy, is the regulated electric and natural gas company that primarily serves 2 million customers here in Southeast Michigan. It's headquartered out of Detroit, has about 10,000 employees. But also DTE Energy has a portfolio of non-utility companies, of which its Power and Industrial Group is one of its 3 non-regulated business units. And then within this Power and Industrial Group is the company that I work for, which is DTE Biomass Energy. We are based out of Ann Arbor, Michigan. I'm calling you from my home here in Ann Arbor. And we've been creating renewable energy from waste biogas sources for over 30 years. We currently operate about 24 biogas projects throughout 7 United States. We have about 80 employees across the country, and our investment thesis is to own and operate these projects under sort of long-term investment practices. Our company has primarily and principally been taking biogas generated from the breakdown of trash at landfills across the country and converting it to renewable electricity. However, as Nick pointed out, with the demand for RNG increasing over the past several years, and we've expanded outside of landfill gas, and now we're primarily focused on developing projects using the biogas created by cow manure at dairy farms, and we convert that to transportation fuel. As I mentioned, our company has had a lot of experience on the landfill gas side, and we started up actually our first RNG project about 20 years ago at a landfill back in 2002, I'm sorry. So currently our project portfolio includes 4 landfill gas-based projects. And because of our experience on the landfill side, we were able to be one of the first to get into dairy-based RNG back in 2018 when we invested in our first set of dairy biogas to RNG projects in Wisconsin. We followed that up by completing construction on 4 additional facilities also in Wisconsin, bringing our total RNG assets to 11. And we've spent well over $250 million developing this space over the last several years. We continue to see tremendous growth and opportunity here, especially in the dairy sector. And we have a directive by our senior leaders to continue to grow this business line, which we are doing. Our latest dairy RNG project is going to be in South Dakota, and we are planning to break ground probably within the next month or so. So I'm going to go through these next 2 sections kind of fairly quickly, as I want to dedicate most of the time on the benefits and the marketplace and the host farm characteristics surrounding RNG. But thought maybe some of you guys might be thinking, well, what's all the attention and what's all this buzz, around RNG and what's creating that? And well, I think my personal opinion, it's a result of both macro and micro level factors coming into play. On the macro side, RNG is a critical component of reducing greenhouse gas emissions. Decarbonization continues to gain momentum and calls for the country to move to a net zero emissions. By 2050 have kind of grown louder and louder each passing day, and many stakeholders are making commitments to rapidly decarbonize. There are numerous drivers for decarbonization, whether that's advocacy or policy focus from both federal and state governments, as Nick has highlighted. There's commitments from utility companies to decarbonize, and there's similar commitments from companies as their environmental, social, and governance actions, or better known as you see the term ESG now more and more. That's being certainly followed more and more by investors. And so negative emissions or offsets from these biosequestration projects, such as RNG, is going to play a critical role in achieving these significant decarbonization. So while global attention on fighting climate change has led to an increase in the popularity of RNG, so has much of a more local efforts and attention. So more and more dairy farmers are embracing their own role in this fight, and they're proactively looking for ways to improve the efficiency of their operations. And RNG can turn what's traditionally been a cost to the farm, that being the collection and handling of manure, into a revenue stream. And so as RNG projects not only benefits the farm itself, but also the local community around the farm, and it provides the farm another way to be a good neighbor in their community. And I'll get more into these benefits later in the presentation. So now I thought I'd spend just a few minutes on the science part of the presentation. That is, how do we actually go about creating the RNG? And so these next several slides will provide a high-level overview on how RNG is created at dairy farms and some detail into the actual science. And the idea of RNG is quite simple, right? What if we could capture methane that's a result of organic decay, and rather than allowing it to escape into the atmosphere, we can use it instead as a beneficial use. So you'll see steps number 1 and 2 here in this slide of making RNG is to actually collect the manure at the farm, and then you deposit that into an anaerobic vessels where that manure will sit and naturally decay, creating the biogas. Next, step number 3 is to collect this biogas and send it to a facility that refines the biogas, such as converted into a product that looks just like fossil fuel-based natural gas. Again, now you've got RNG. RNG is fully interchangeable with this conventional natural gas and can be transported in our country's existing natural gas pipeline infrastructure. To get the RNG into that pipeline, though, one, if the farm is located close to a pipeline, then we could connect that directly to that pipeline with another pipeline, and you'll see that in step number 5. However, if the farm is just too far away from that pipeline, then what we have to do is we have to compress and load that RNG into a specialized trailer, and we have to then actually truck that to an offloading facility that is located adjacent to a pipeline, where then we can unload it and then inject it into that pipeline. So now that you've got the pipeline, the RNG into the pipeline, it can now be delivered to the end customer. For us at DTE, that's fueling stations out in California that are designed to pump compressed or liquefied natural gas into vehicles. And again, I'll get into sort of that demand side a little bit later. I'm probably stating the obvious to this audience, but it goes without saying that manure management is certainly something that dairy farms need to pay a lot of attention to, given its potential impact to the environment, as well as its local community, and then just frankly, the large cost of handling this manure. So the dairy farm industry has been consolidating. Smaller farms and herds are being gobbled up and acquired by larger farms, which has led to farms with thousands and thousands of cows in one location. And these farms need to address now the large volume of manure that is coming in as part of that consolidation. So traditionally, manure is collected by a farm. It's usually placed in large open lagoons, where it either breaks down and evaporates, or maybe some of it is taken out of the lagoon and land applied as a fertilizer. The collection of manure, however, in an anaerobically sealed container will capture that biogas that's created when that manure naturally decomposes. And as you can see from this slide, right there, the collection vessels can vary substantially. That top one, the covered lagoon, is just simply taking a tarp, if you will, and covering an existing lagoon. Or what we can do is construct containers that specifically are designed and optimize the collection of that biogas, either above ground at the bottom or below ground. That middle one is kind of an underground swimming pool, if you will. You can see the top of it here in that photo. Okay, so now that we got the biogas has been captured, we now need to clean and convert that into pipeline quality renewable natural gas. Raw biogas coming out of a digester is typically around 58% methane, 41% carbon dioxide or CO2, and the remainder being hydrogen sulfide or H2S and some other small volume of gases. And there are several ways that biogas can be processed and refined into RNG. I'm not going to delve into a bunch of the details here around each technology, but just rather wanted to kind of point out and highlight that there certainly are different ways to do that. They all work to varying degrees of success. They all have their advantages. They all have their disadvantages. And if anyone would certainly want to spend more time talking about that, we can certainly connect individually to do so. I do, however, want to show and spend just a minute kind of briefly describing the process that we at DT have chosen, for at least for our initial dairy-based RNG projects, and that's called a membrane technology. So the slide here shows both a cartoon and a cutaway image of a membrane bundle. And the membrane is basically can be described as a collection of porous straws. You can see on the bottom right, that's sort of the cutout showing the fiber bundle. And in a single commercial scale cartridge, that fiber length can be as long as 1,000 miles. And so what happens is the individual components of the biogas have different diffusion rates through the walls of the membrane. So this allows kind of this controlled separation of the biogas. So methane can move through the straw lengthwise to the other end, while the less desirable components such as CO2, carbon dioxide, that gas can permeate and move through the walls of that straw, where then we can collect and collect that gas for destruction. This is one of our RNG facilities at a dairy farm in Wisconsin. You can see kind of in the background that long roof. That's one of the cow barns. As you can see, the RNG facility is not some giant, industrial refinery looking behemoth, but rather has a fairly small footprint. The image on the bottom right is of the membrane skid itself. You can see again, that's where that separation of the biogas occurs. And those long tubes, it's probably hard to see here, but the membranes are contained inside those tubes. Of course, there's some other components that's not shown, some compression equipment and some other auxiliary equipment. But you can see, I wanted to give a general sense for the footprint of these type of project at dairy farms. Okay, so we've created the biogas, we've cleaned it up into a pipeline quality product. Now we have to get that to the market. Very often these dairies are in very remote areas that aren't near a point where we can conveniently and economically inject into a gas pipeline. So what we've done at several sites there in Wisconsin is employ what's called a virtual pipeline, where we can truck the RNG to one of these centralized injection facilities that we build and operate that is right on top of the gas pipeline. And again, we'll compress and load that into tube trailers and then truck that to this. And those trailers are specifically designed for handling this type of operation. So to wrap up this section, I just wanted, again, here's a picture of another one of our projects in Wisconsin. This one also has digesters. So I just want to give you kind of a scale for the sense of these projects. Right now, DTE and others in the industry are building projects at larger size dairies to take advantages of economies of scale, or actually rather, avoid the diseconomies of scales of smaller farms. But technology and investment in this RNG space certainly continues. And as it's done, smaller size dairy farms are starting to become more economically viable, modularizing the processing equipment, and using different, maybe less costly digester designs are leading the way in this technology investment area. Also, as Nick mentioned out, developing projects kind of in that hub and spoke or pod basis certainly helps, where you can connect multiple farms via pipelines and digesters into one RNG processing facility, because sometimes a farm is just not big enough to support a standalone RNG project on itself. So now I just want to get into the benefits for the dairy farm itself for hosting a dairy RNG project. So as I'm sure everyone here knows on the call, most farms are very, very well run operations and certainly need to work hard to maximize value from everything that they do. Modern dairy farms can truly be integrated operations, as this slide shows. And ideally, what the end goal would be what's called a closed loop system that can be created, where the digesters and that RNG processing facility be an important part of that system. Milking cows, along with producing 6 to 8 gallons of milk a day, can produce well over 100 pounds of manure per cow per day. And of course, this volume will certainly vary substantially based on the size and the type of the cow and the location and the feed ingredients. But nonetheless, you're dealing with a lot of manure from cows. And with a digester, that manure can be directed through the digester where the biogas is created. As that manure composes, of course, now we can take that gas and we can put it to a beneficial use, such as RNG. The manure that comes out of the digester is now referred to as digestate. And some farms can use this digestate as bedding for the cows. They can put it through some presses and actually use that as dry bedding and return that bedding to the barns. Or this digestate can also be land applied to crops. And because it's got reduced pathogens, because it went through the digester as a result of that anaerobic process, this digestate can be applied over a longer period of time than, let's just say, the raw manure itself. You can also further then, of course, take that digestate and further process it to filter out even more of the bad contaminants, the nitrogen, the phosphorus. You can basically get it down to clean water if you so desire. So now there's certainly some environmental benefits for the owner as well as the local community, and I want to kind of just point those out here as well. So. Remember that biogas created from that manure is approximately 58% methane and 41% carbon dioxide. And methane, as Nick pointed out, is a very, very potent greenhouse gas, anywhere at least 25 times more potent than CO2. But however, both gases are a very large, powerful pollutant. So a digester collects that biogas, that harmful greenhouse gas that otherwise would have just been naturally released into the atmosphere. As raw manure is either sitting in an open lagoon or it's sitting on land as a fertilizer. We're going to capture that and we're going to then put that to a beneficial use. So certainly environmental benefits there. Also, again, that manure coming out of the digester, now referred to as digestate, certainly doesn't smell as bad as some of the volatile pathogens have been destroyed. So That's really good for community relations and for being a good neighbor. And without a digester, that farm that collects that manure can land apply it for fertilizer. However, large quantities of manure requires a large amount of acreage and can have some seasonal limitations depending on where you're at. Whereas ever digestate could be a land applied later into the year and could require less land, again, based on kind of the permitting requirements of where that farm sits. The reduced pathogens can also significantly improve the water quality, as this digestate is not raw manure. And then finally, the resulting RNG is, when it's used as a vehicle fuel, it will displace the regular gasoline or regular diesel fuel for in a vehicle, which provides yet another environmental benefit. And so certainly those are some really good reasons to do this project, the environmental benefits, but certainly also provide farms in the surrounding areas with economic benefits as well. So host farms will participate in the economics of an RNG project. They will receive payments typically from the RNG producer. And believe me, these payments can be significant and certainly welcomed by the farm in today's really tough milk pricing environment. These RNG projects bring new jobs to rural America, not only for operating the facilities, but also for the ancillary jobs created to not only construct, but then support these projects. So hopefully that provides an overview of kind of the how and why RNG is created. So then I wanted to next maybe just bring a little bit more insight into the demand side of the RNG equation. As I had mentioned, I think as Nick mentioned before, most of the RNG produced today is used as a vehicle fuel. There are both federal and state programs that incent the use of RNG as a transportation fuel because RNG can be used in compressed natural gas or liquefied natural gas powered vehicles. The state of California certainly is the most aggressive state program out there, and currently most of this RNG is transported through the existing natural gas pipeline system, where it ends up in the state of California and ends up in CNG and LNG fueled vehicles. More and more states, however, are implementing similar programs. And we are also seeing more demand now over the last 6 to 8 months in other parts of the market sectors. Now, the number of companies who are looking to reduce their carbon footprint continues to expand. Initially, this was mainly focused on electric needs. So a lot of folks were kind of going out and buying wind and solar powered renewable electricity. But now they're looking to green up their gas needs as well. And RNG certainly can do that. Finally, natural gas utility companies are out actively seeking RNG as gas utilities are making net zero emission reduction statements. Our parent company, DT Gas, recently, earlier this year, made that commitment as well. And most gas companies, utilities are offering their customers who are looking to be part of this climate change solution, the ability to reduce their own carbon footprint. So, I'm sure you've maybe seen from your own gas utility an option to maybe check the box and, for a few more dollars a month, you can kind of say, hey, I want to buy green electricity, or I want to buy green gas. So we certainly see demand has ramped up as a result of that. As most of the dairy, however, projects go into vehicle fuel, I decided to just spend just 1 minute on that part of the business. Because of the drive to reduce emissions and to lower emissions, rates of RNG earns a strong premium. Again, there's 2 government incentives. Certainly the LCFS, low carbon fuel standard, which is in California, certainly drives a lot of that. But then the federal government has another program called the Renewable Fuel Standard, or RFS. And that was certainly developed to encourage the development of domestic fuels. And both programs are additive. So if the produced RNG finds its way into a vehicle fuel, a gallon in California, it'll earn both the federal RIN, what's called a federal RIN, and then the state of California LCFS. And so you can see here in this slide, the pricing can certainly vary and it can be volatile, but you can see, you can get upwards to $80 per MMBTU of RNG. And if you want to compare that to the actual physical commodity, the brown natural gas of $3 to $4, you can see just kind of where and how this demand for RNG is leading to this to the economics that we're seeing today. So I thought I'd conclude this presentation just on kind of how we're looking at growing the number of dairy-based RNG projects. So Certainly, the popularity of RNG continues to increase, and companies like ourselves, like a DT, are out there actively developing additional projects. There are definitely over 250 manure digester projects in operation, but still only a fairly small number of projects that turn most of those biogas into RNG, and most of those are today in the state of California. It's hard to really track exactly how many projects are out there, but the current thought is certainly 20, maybe 30, a lot in development as well right now. But we certainly see tremendous growth and opportunity, and we're not alone. And AgStar believes there are over 8,000 additional farms out there that are potential host candidates. So it's certainly an exciting time for sure. So what does make a good candidate for an RNG project, right? And certainly there are a lot of numerous factors out there, but several key ones I just wanted to kind of focus in on today. The most important one is probably the size of the host farm. And when I mean size, I kind of mean the herd size. That's the source of the feedstock for the RNG. As I mentioned before, the larger the farm is, the better. But for us at DTE right now, that probably means a minimum herd size of probably 5,000 cows for a dedicated RNG project. Now if there are several smaller farms that are close enough to each other, then we create that pod where we can either collect the manure or the biogas from each of these different smaller farms and dedicate it into one combined RNG processing facility, again, to kind of take advantage of some economies of scale. So herd size is certainly a big point. The other one is the manure quality and the handling practices can have a significant impact on project viability. Collecting manure from cows and cement floor cross bent barns, like typically what you see in Wisconsin, is quite different than saying to try to collect cow manure from open dirt pastures, maybe that you see common in the western states. Manure collection processes, whether it's scraping, flushing, or via vacuum trucks, can certainly impact the quality of the manure and will impact the digester capacity that is needed for the subsequent biogas production. If cows are bedded on sand, right, additional processing of the manure could be required to separate that sand, from the manure as well. So those are all important things that, as a developer, we look at. And then finally, as I mentioned before, another critical factor is just the location of the farm. Ideally, it's located really close to a pipeline that we can do a direct pipeline. As again, if not, then we're going to need to truck that gas, and that certainly can add some cost and complexity to the project. So that's what I have for you today. I certainly appreciate everyone taking time to listen in, and hope you find RNG fascinating and exciting like I do. And certainly, have time for questions, or if anyone wants to follow up with me, here's my contact info.
Thank you, Kevin. Tons of great information. So we've got plenty of questions. So our first question here is someone asked, what is happening with the effluent from the digesters?
Yeah, sure. As I mentioned, right, certainly that digestant or that effluent coming out of the digester, ideally, if it can be put to a beneficial use, that would be great. So again, a lot of farms like to use that digestate as a bedding. So we can return that manure after it's been through the digester. Maybe it sits there on average maybe about 20 days. It'll come back and go through a series of screw presses to kind of further separate that water out and get that really dry, maybe get some additional heating and some drying, and then literally just put that right back into the barn, and the cows can use that as a bedding. So that's, it's probably the best thing that people can use, farms can use. If they're on sand, or if they don't want to use that as bedding, then it can certainly then be used and put right back into a lagoon. So if the farm does have an existing lagoon, that can be put on there, or it can be stockpiled, on a cement slab. Or I guess, as I mentioned before, ideally, that effluent then that's kind of the first stage. So then there could be additional processing that folks can set up to take that effluent and then further refine that, further separate the solids and the water, and some reverse osmosis and some ultraviolet technology to then get that into kind of clear, clean potable water.
Yeah, that's great. I'll just add on to the sort of the continuing to refine the effluent. There are a number of systems out there that can actually extract the nutrients out of the manure as well too into phosphorus and nitrogen that could be used as they turn it into like a pelletized product. That, of course, just like the renewable natural gas systems, requires a lot more volume of effluent to be economically viable. But those systems they're continuing to try to bring them down to smaller and smaller scale. And that is beneficial in that sometimes that fertilizer, if it is turned into a product, can be sold to other farms and distributed in areas across the country, like for example, the Chesapeake Bay, where there's nutrient challenges in the local waterways, and some farms have provided too many nutrients on their field. That's a good way to transport it out of the water system and create another value added product.
So lots of different options. I also think everybody probably saw a lot of presentations today about lots of great things you could do with the manure, and it's the same with the digestate. Okay, the next question some folks had is, so I think Kevin, you hit on, and Nick both talked about, projects going in, and we see a lot of them going on large farms. Can you guys talk about if you've seen any small farms integrating these kinds of things, or do you see possibilities for small farms, or do you think it's just going to be for a while just large farms until maybe something changes?
I can take this first, Kevin, and be interested to hear your thoughts too. There are a number of farms that are smaller farms that are having anaerobic digester systems. For example, in Massachusetts, there's a few farms. One, Barway Farms, has 250 cows, but they're also bringing in offsite food waste from local facilities where there's available food waste. So that food waste boosts the biogas production and makes the system more economically viable. That system is producing electricity, not renewable natural gas, but again, at a higher scale, I could see, Kevin, you kind of gave out the number of 5,000, I imagine, 5,000 cows to make the system feasible. I imagine maybe that system or that number could lower a little bit if you're able to supplement the manure with food waste, which is happening a lot across the country.
Yeah, no, that's a good point. Certainly, the ability to, either consolidate smaller farms, right? If there's several farms, that's probably the best way to try to get a project done at a smaller one. But a standalone is certainly tougher to do. Just if you're just relying on manure, bringing in food waste or other sort of waste can certainly boost gas production. You could get into some issues around how the federal and the state programs look at co-digestion, and there's some hurdles there. I think what can be helpful as I mentioned in my presentation, technology is certainly and as the amount of energy and time and resources are put into RNG, people are building better mousetraps and looking at different technologies. Europe's been doing this for a lot longer than we are, so we see a lot of European vendors, starting to bring their stuff into the United States, and there's certainly some smaller operations there. The other thing is just farms that have existing digesters, so maybe farms that have digesters already built that maybe we're doing electric projects. That'll give a project a big head start, because not having to invest in a digester certainly helps make a smaller project more feasible economically. And then also, just working, we're working with federal and state governments to see if, are there additional incentive programs? Are there tax rebates? Is there other production credits available to help kind of subsidize the cost of some of this technology? Again, that would also certainly kind of help drive down the number of cows needed to make a project economical.
A follow-up question I had to that is that, so when we look at individual projects versus cluster projects, do you think there's more challenges that go along with cluster projects that you might not run into with individual projects?
Yeah, I mean, it's going to be, especially if the projects are owned by different companies or different farms, then, trying to get everybody together certainly is challenging. You still have the challenge of, okay, do I need to build individual digesters and then collect the biogas and send the biogas to one RNG facility, or am I going to collect all the manure and send manure through pipelines to one central digester facility into one? So there's pipelines, there's right of ways that kind of can kind of get tricky for those pod type projects. But it's not, certainly a lot of people are doing. I think that the Kern County, that Nick mentioned, certainly is a good success story. They've got miles and miles of pipeline. We've got a project in Wisconsin that we've combined 3 different farms locations into one central processing. So it is doable, but it just takes a little bit more effort and coordination.
Next question is, somebody asked if there were ways to work with solid manure. So I think a lot of the systems people see are the ones working with liquid or slurry manure. And then have you guys seen any projects on solid manure being integrated?
You definitely need a high volume of liquid to make the system operate efficiently. I don't have the numbers in front of me, but in our AgStar project development handbook, we have a table in there which shows the different amounts of the different amount of liquid in manure that is feasible for different types of systems. Covered lagoons, for example, need a lot more liquid than a complete mixed system, but there's different ratios that are sort of best practice guidelines for that. But certainly you need a good amount of liquid for these systems to work.
I was just curious, have you seen any of like the dry digesters that we traditionally think of maybe going more with food waste? I'm not sure if a lot of those have been looking at converting to RNG in some cases, but it's possible, I guess, that you could look at a solid manure in that system.
That's a good point. There's not many solid digesters in the U.S., so I don't have great experience in that. I know University of Wisconsin, Oshkosh has a great system up there, but they're mostly doing food waste. So I'm not sure how it would work on a livestock facility.
I think it's very possible. We just don't see many of them here. I think there is another question that kind of ties a little bit to the food waste, is that someone was asking, how does the federal government, the RIN credits and the others with AD, with co-digestion of food waste change? So if you're adding other substrates, does that change the value?
It can, yeah. So the federal government and the program it has classifies different types of feedstocks and assigns different values, if you will, classifications. And so manure-based RINs are certainly a lot more valuable than a food waste RIN. It could be 50% more value. So there's a lot of rules and regulations. If you commingle that, it's technically possible. But there's a lot of more scrutiny and just a lot more bookkeeping and sort of a risk of what the federal government doesn't want you to do is get the manure premium for food waste. And so people are doing it because, again, you do get a nice spike in gas production, but it comes with a lot of additional burden in administration. So we at DTE have chosen not to do that so far.
So are you seeing a lot of the facilities that are switching to RNG? Are they new facilities mostly, or do you see that it's facilities that were already existing with a different biogas and use like a combined heat and power that are now transitioning to RNG?
I can just speak to our experience of AgStar collecting data in this area. I think the majority of RNG projects are new systems that are coming online, but as I pointed out, there's a number, and Kevin alluded to, there's a number of projects across the country where it's happening. I don't have the ratio, but I think there's some of both, but a lot more new projects that are being built.
Yeah, I think from a developer standpoint, right, it's I guess the low-hanging fruit, if you will, would be a farm that already has the digester there, right? Because again, that's one less thing that a project has to invest in. There's a nice history there, maybe you've got some proven gas production. So at least the first set of projects that we did were all at farms that had existing digesters, and a lot of that was put in. And Nick mentioned, right, there was a lot of combined heat and power projects that were, a few years ago were economically viable. They've since kind of rolled off those PPAs, and so there was kind of a nice set of projects that we could then kind of come in and rip out the old engines and put in the RNG facility. But most of those farms that have digesters that are available to do RNG have already kind of been spoken for and either are up and running or under construction. So now we're that next wave of projects, at least for us, was at farms that didn't have the digesters, and again, you need to go to those bigger farms to kind of make that capital pay for itself.
So are economic limitations still the biggest hurdle to these new installations? Or are you seeing that there's other operational or regulatory hurdles?
Yeah, no, that's a really good question. Certainly the economics are tough. These are, even at 5 or 10 or 15,000 cows, which is a very, very large farm operation, the amount of biogas that's created is still, in the kind of the renewable space, a relatively a small project. And so, the economies of scale can get hard for smaller projects like dairy gas. But thankfully, the federal and the state programs are at least incenting us for us to make those investments and others in the industry. So certainly economics are certainly a big task, but there are a lot of hurdles, right? There is there's still some, the pipeline, the interconnect. So getting it into the pipelines can be troublesome at points. There's a lot of education going on out there to kind of educate pipeline companies that maybe say, hey, I'm nervous. I don't want RNG into my pipe, right? And we have to do a lot of education and about why this is, interchangeable. This is just like fossil fuel gas. There's a lot of metering set up to kind of make sure that folks, the pipeline companies, can get comfortable that the gas coming in is meeting the same spec. Sometimes we get put at a higher spec than the fossil fuel based gas. So that can certainly be a troublesome as well. And then, the vehicle fueling pricing, can be volatile. So, it's a lot of it is policy and legislative controlled. So who's in the White House or who's the EPA lead and what is their view on renewables certainly can help dictate that price. California, Washington, all these other states, there's a lot of kind of moving pieces that people have to get comfortable with.
I have a follow-up question for you, Kevin, on that point. RNG facilities or farms that want to have an RNG facility, you said the number of cows you need is 5,000. So obviously those systems are a lot more expensive. Is it the RNG equipment that is sort of the biggest cost hurdle, or is it a combination of that and the challenge to connect to the pipeline?
Yeah, no, that's a good question, Nick. Certainly the RNG processing can get expensive when you look at it on a kind of the capital, right? So this is millions of dollars, not hundreds of thousands of dollars worth of equipment to install that interconnect. So it's kind of infuriating and kind of funny to see some companies will charge, say, hey, yeah, you can connect into our pipeline and we'll charge you $300,000, to do so, to literally, cut a hole in their pipe and, let us put our pipe into theirs. Others charge millions of dollars. They'll say, yeah, you can connect, but it's going to be $2 million. $2 million is a significant cost that project then has to burden. But yeah, so I guess it is a combination of everything, and these operating costs as well, right? I mean, you're gonna have to pay an operator, a full-time person to kind of manage that system, and whether they're producing, based on 1,000 cows or 10,000 cows, it's one person. So that's the sort of diseconomies of scale that that we need to overcome.
So do you feel pretty comfortable that the incentives that are available right now will remain consistent do we see that that's pretty strong to remain consistent for long enough to get these projects developed and make the money back?
Yeah, no, I think we certainly are bullish. I mean, we've done a lot of our homework, both on the federal side and the state side, for the vehicle fueling programs to make sure that, we don't go sink a lot of money in and then those projects, those programs, get terminated or altered significantly. And I think we certainly feel bullish to make those kind of statements and make that investment. And then also, right, just the amount of demand for RNG outside of even the vehicle fueling stations, big companies like Google's or the Apple's, right, that are looking to be green, or the utility companies that say, we are going to be net carbon zero by 2030 or 2040. There's just more demand, that comes in every day. I mean, some of the gas gets shipped over to Europe, and there's some European demand. So there's certainly demand. There will always be a demand for green gas.
I wanted to ask a few questions about kind of as we, what we've seen in some states. I know California is driving a lot of this in certain ways with their incentives, but they also have significant grant programs. I know we saw Vermont had some development. Do you think there's additional things that could support further development? Is it really just providing that grant funding to get some of these things out? Or do you think there's other needs that states or the federal government could support?
Yeah, I guess I can start. Yeah, so I think certainly, RNG, as I mentioned, right, doesn't have any benefit, doesn't have any sort of grants or incentive. I mean, there's some, I think the federal government has a REAP program. So there's some incentives out there to kind of help farms, kind of defray some of the costs of the digesters. Certainly something like that could help, right? And I think there's a scoring system and there's some other things that, maybe can be kind of be tweaked and worked on to maybe kind of open up the amount of farms eligible to do that. Certainly tax incentives, so production tax credits and things like that kind of helped boost that electric generation form a few years ago, right? If there was a similar sort of incentive, that will certainly help defray the economic costs and provide maybe lower that barrier for number of cows that need to be for a farm. I think continuing education on the interconnect and pipelines and different specs. Every pipeline company has potentially a different spec, the gas specification that RNG needs to make. And some of them are quite burdensome. And so I think having maybe a national standard or maybe just an acceptable industry standard would certainly help.
I had one question. I know, Nick, you mentioned that they were diverting food waste into some of these to support some of the laws developing in other places. Do you know if that's been difficult to get the infrastructure to support some of those? Or does it seem like there are enough digesters and composting situations to support that already?
Good question, Becky. I know that some of the states in the Northeast, they set a target of a future date. So I want to say some of the first food waste diversion laws were put into place in like mid-2015, like maybe around 2015 or so, saying that by 5 to 10 years down the road, these large generators need to divert. So there's been a sort of a lag period before it's been required, of which infrastructure has begun building up. I don't know. It's a really good question. I don't know what, for example, in New York, like, do they have the capacity to be able to handle that waste?
I did want to ask one more thing. I know we didn't have a farmer here today to talk, but Kevin, as you work with them, or even Nick, if you've talked to them, what are their concerns as they're moving through installing some of these, or like some of the issues that they bring up as they're kind of deciding how they want to, if they want to install these kinds of systems?
Yeah, I guess I'll start, Nick. It's interesting, right? Because these farmers are inundated. I think again the popularity of RNG is such that companies like big companies like DTE are out there are trying to talk to farms about providing a project on their site, but they probably get multiple calls a day, and everybody's throwing all these numbers and facts and figures, and so I think a lot of these farms are just kind of confused, and it's kind of tough to kind of weed through kind of what's real and what's not real out there, because a lot of folks say they're going to do RNG and they want to do RNG, and a lot of people don't know what they're talking about, and they saw this before, right? So a lot of times farmers will say, hey, a few years ago I had everybody wanting to do an electric project on my on my farm, and now electricity, I can't sell electricity for more than its cost. So there's some skepticism, like, okay, is this the next thing? And 2 years from now it's going to be something else. So there's some skepticism there. The other thing, I guess, is they've got so much other things to do. The last thing they want to do is here's another thing on my farm that I need to worry about or to manage. And so so it's that relationship between the RNG project and what we try to tell them, and ideally an RNG project is set up that, hey, we're going to basically stick a pipe, or you're going to put all your manure into this location, and then we got it from there, right? You don't need to worry about anaerobic digestion operations or RNG production, right? You bring us the manure and we'll give you back the digestate. and a check. I think that's in their mind, that's the perfect opportunity because they've got a lot of other things to worry about.
Yep, I'll echo what Kevin said. From some of the experience I've heard is, the inundation of companies coming to them and not sure what is a good opportunity, so I'll just offer this to you, Kevin. At AgStar, I think we share the same goal of trying to get more systems built. So however we can be an intermediary or, a voice of trying to provide an independent voice to, some of these projects, would love to work with you to help educate the farm community and help vet some of these projects. The other thing for renewable natural gas is, of course, the price and how the economics all will work out. Farms operate on really tight margins as is, and multi-million-dollar investment can be really scary upfront and can be enough, I would say, in a lot of situations to just avoid for farmers to even kind of pursue. So trying to figure out a way to explain the economics in a clear way, and in companies like DTE that have a proven track record certainly are a good answer to helping avoid some of that perceived risk.
Well, I think we've hit the end of our time. And so Kevin and Nick, I really appreciate all your information. I feel like I could probably ask you guys questions for another hour, but I think this topic is really exciting, and I hope we see more installations. I hope everybody out there takes this information and can use it to help this progress even farther. And so I really want to thank both of you for being here today. It's always awesome to be willing to just take random questions from everybody. So you guys did a great job, and thank you very much. And I want to thank all of the speakers and everybody today for everything they've done. And I'm going to hand it off to some of the people that I think Heather has put up an evaluation there for you. If everybody could complete that, it helps us to build our program for the next year, and then anything else that is out there.
Thank you, Becky. Before we leave today, I want to make sure we thank everybody, including our speakers, for attending our first virtual conference. I think it was a great success because you guys all showed up. We couldn't have had it without you. We also couldn't have had it without our sponsors. So I would like to once again thank our generous sponsors for making today's event possible.